Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on multistage centrifugal pumps. So in our last lecture, we have discussed about the theory part of multistage centrifugal pumps, and we have discussed about the working of this multistage centrifugal pump also. So based on that concept, we'll solve a problem. So here I have taken a question, a three-stage centrifugal pump. So here multi in the sense three-stage, multi-stage centrifugal pump has impeller 40 centimeter diameter and 2 centimeter wide at the outlet condition. The vanes are curved back at the outlet at 45-degree angle, reduced the circumferential area by 10%. The manometric efficiency is 90% and overall efficiency is 80%. So determine the head generated by the pump when running at 1000 rpm, delivering 50 liters per second. What should be the horsepower? What should be the shaft horsepower? That means we need to calculate two things. One is head generated by the pump. Another one is the shaft horsepower. So two things we need to calculate. Before that, we need write down the data given here. So what are the data are given in this question? So the concept of this multi-stage centrifugal pump we have discussed in our last lecture. Like it is of two types are there. One is to increase the head, and another one is increase the discharge of water. So here you can see that three-stage centrifugal pump. So we can understand the n value equal to 3. That means number of stage is 3. Okay, and diameter is given. So diameter of the impeller at the outlet condition, that means D2 is given. Okay, D2 is 40 centimeter. So 40 centimeter we can convert into meter. So we can write this is 0.4 meter. So next one, yeah, let's write in this same line. This is B2. B2 in the sense width. So that is width 2 centimeter the outlet condition. That means 2 centimeter width is there. So 2 centimeter also again we can convert into centimeter, meter. That is 0.02 meter. And vane angle given at the curve back at the outlet condition. So vane angle is nothing but we know that is phi. At inlet condition theta, outlet condition it is phi. So phi is given 45 degree. And reduce the circumferential area by 10%. So the area reduction of 10% reduction is there. So this one we can write the reduction of area how much we don't know, but it is given in the question that the reduce the circumferential area by 10%. So first of all we need to identify the area. So area of the flow we need to calculate, and from there we can just reduce the 10%. So 10% in the sense nothing but 0.1. So we'll calculate the area of flow at outlet condition. Area of flow at outlet condition. So what is the formula for this? We know that the formula for this we need to calculate actually. That is, area of the flow you can write like if we know Q equal to AV. So or else we can calculate another one value is there, that is 0.9. okay, 0.9 into area. So that is pi D2 and this is B2. So we can write in this way also. So area of the flow at the outlet condition you can write in this way like 0.9 into pi into D2 is given 0.4 and this is B2 given 0.02. We can calculate this and we can find out the value of area of flow at the outlet condition. And apart from that, the manometric efficiency is given 90%. So manometric efficiency is given 90%. We can write this is 0.9 and overall efficiency is given eta O. This is 80% and we can write this 0.8. And speed, the speed of the pump n is given 1000 rpm. Okay, So these are the values are given in our question. And we need to find out the head generated by the pump when it is running at 1000 rpm and what is the shaft horsepower. So yeah, so we need to calculate the head generated by the pump. That means we need to calculate the manometric head. So manometric head will be calculated. The formula will be there for this that can be only identified from the manometric efficiency. So if you remember the manometric efficiency formula, let me write this. Manometric efficiency equal to, this is GHM by, this is VW to U2. This is the formula, and from this formula we can calculate the value of HM, that is the manometric head or the head generated by the pump. And the next one is, that is shaft horsepower required. So shaft horsepower required, that means we can calculate, that is from the overall efficiency actually. So we can write overall efficiency equal to so power output of pump. This is power output of the pump, and we know the formula, like our efficiency equal to output by input. So this is power output of the pump, and here again we'll write power input of pump. So output by input. So here this is input is nothing but our shaft power. So overall efficiency you can write, this is power output of the pump. So output of pump, and here we can write this is shaft power. So again we need to calculate the shaft power, in the sense shaft power can be calculated like power output of pump divided by, this is overall efficiency. Okay, so here let me write power. This is the two formulas are there. By this you can calculate. Now thing is that we need to identify, this power is not given. Power output of the pump, it is not known to us. We need to calculate that. Again here if you come, this value need to be calculated. This is given, and we need to calculate VW2 and U2. So these three things we need to calculate here. Then we can solve this. Now what I'll do, so yeah, in this, if you see in the data given, one more data we have not written, that is 50 liter per second. That is the discharge given. So let me write, this is Q equal to 50 liter per second, and if we can convert into meter cube per second by dividing 1000, so we'll get 0.05. This is meter cube per second. This is our discharge. So to calculate this VW2, which is present at the outlet condition, that will go to the next one. First we'll calculate the U2. So U2 is nothing but let me use another color. So first one, the tangential velocity at the outlet condition. Tangential velocity of impeller at outlet condition. Okay, so this one we know that U2 equal to pi d2n by 60. Pi d2 n by, this is 60. So here we can write, this is pi into d2 value is given 0.4, and n value is given 1000 rpm, and this is our 60. So 60 here we can like 3, and this is 50. 3 will be cancelled, suppose 50 into 0.4, so that will be near about 20. So this is 20 into 0.03 something will be there. So near about it will be some value of 20 into something will be there, 20 point something value will come. Anyway, we'll solve this with the help of our calculator. There will be no doubt. So pi into, this is 0.4 into 100. Let me write 100 divided by 60. 2.03. let me check it again, because 100 into pi into this is 0.4, correct, and divided by this is given 60. So it came near about 2.094. Okay, actually the value 2.094, let me write here. Anyway, that much meter per second. So 2.094. So pi d to n, everything is correct. Okay, here I had done mistakes, because if you see the value is given 1000, I have taken 100, and I have like you can cancel also 100, so it will be 500. Okay, so one zero cancelled, then after that 100 is there, then after that, okay, I have done 50. Anyway, so that is my mistakes. So one more 10 will be multiplied in this, will get. So the value is actually, this is 20.94, this much meter per second. This is our tangential velocity. Okay, so some confusing, the value is very small here, though we are multiplying here like this zero was not seen properly to me. So actually 1000 it is. Okay, so anyway, we got the value of u2. Now the next target is for us, this is vw2. So vw2 is nothing but, we know that at the outlet condition, if you see, if you remember the pump outlet condition, there our 10 phi angle will be, okay, 10 phi angle will be written in terms of vf2. Okay, vf2 divided by this is u2 minus vw2. This was the formula for at the outlet condition. Okay, here phi value is given to us, correct? Phi value is given, u2 value calculated, and vw2 need to calculate, but vf2 also not known to us. So in the vf2, what I'll do here, so velocity of flow at the outlet condition, that is vf2. So vf2, I can write vf2 into a2 equal to, this is our q, let me q write, discharge equal to vf2 into a2. Now I can write vf2 equal to discharge by area. So discharge equal to how much is given, 0.05. okay, and area value, area of the flow, okay, area need to be calculated. Here I have not calculated, let me calculate this. So here I'll write area equal to, this is 0.9 into pi into 0.4 into 0.02, 0.0026, like this is the value of area is given here. So let me write, this is 0.02, 0.02261, this is 6, this much meter square. Okay, 0.0226 meter square. Okay, this is our area. This much value is enough. Now we need to put the value here, actually 0.02 by 05 by 0.0226. So we'll get the value of vf2. So let me do this, like 0.05 divided by 0.0226, 2.212. This is our value, 2.212 meter per second. This is our flow velocity at the outlet condition. So second thing we got. Now we'll write, this is phi equal to, okay, here we need to calculate the value of vw2. So I'll take this term in this left hand side, for 10 phi I'll take it here. Then at u2 I can take it to this side, and v2 I'll keep it other side, like so. Finally what I can write, vw2 equal to u2 minus vf2, vf2 divided by 10 phi. This one I can write. So let me solve this vw2 equal to, u2 already have calculated, 20.94 minus vf2, just now we have calculated, that is 2.212, and divided by 10 phi. 10 phi value, how much phi is given, angle 45 degree. Okay, Now I can write this. Yeah, okay, I'll do one thing. Let me take this help of this 20.94, and this is minus bracket start 2.212 and divided by this is 45 given 10 equal to 18.73. 18.73 we can write here. So this value we got here now, total 18.73, this much meter per second. This is the value of VW2. So why I have calculated the VW2 value? To find out this HM value, correct? Now just put this value in the HM like in this equation, so you can find out. The next we'll do here, I'll take it to here. Yeah. Now HM I'll keep it one side, remaining value I'll take it to the other side. That means HM if I keep it one side, then this is manometric efficiency, yeah, into VW2 into U2 divided by G. So manometric efficiency is how much? That is 90%. So this means 0.9. VW2 just now we have calculated 18.73, and U2 also we have calculated, that is 20.94, and divided by G value 9.81. So now let me solve again. 18.73 multiply 0.9 multiply 20.94 divided by G 9.81, 35.98 we got, that is HM. So this is the manometric head, 35.98 meter. This is our answer. Okay, this is our answer. This is the first answer, this one. And the second answer, if you see, this is our second answer. In the second answer, if you see, short power need to be calculated, overall efficiency given, power of the pump need to be calculated. So the B point, let me write here. B point is nothing but power of the output of the pump. Power output of pump. This need to be calculated, correct? So here what I'll do, this is very simple. If I want to calculate in terms of watt, so what I'll do here, this is power is nothing but what is the weight of the water lifted and total head. Total head need to be written. So total head how much is there, that I don't know. So that need to be calculated. So total head I'll write as H. Okay, W into H by 1000 here. So W equal to what? W equal to, you can write, this is rho, G and Q. And total head equal to what? Here I have calculated only that manometric head I have calculated, correct? Here this is only calculated manometric head. Now the total head will be like how many pumps are used. So total number, if you see, total 3 stages centrifugal pump, that means number of head, the number of pump is 3, multi-stage, number of stage. So here to calculate this total head, we need to like 3 into HM, this on behalf of H, and divided by 1000. Then only I can able to calculate this power. So now write this P equal to rho equal to, let me write all this value 1000, and this is 9.81. Q value already given 0.05, and here HM equal to, just now we have calculated, that is 35.98, and here again 1000 is there, that is 2. So this will be cancelled, so you will get the power of this. So let's solve this one. 35 is there, yeah, 35 is there, then just multiply 0.05 and into 9.81, so 17.64. So here, okay, here one more thing, 3 you have not multiplied, just multiply into 3, so 52.94. So this is 3 is there, this one. So 52.94 kilowatt, this much power, okay, at the output condition of the pump. Now what is required? This one, shaft power. So we know that the shaft power equal to power of the output, like power output of the pump. So power output of the pump is nothing but this is 52.94, and what is the overall efficiency? That is 0.8, 80%. So we can write this 0.8. So in the 0.8, if you divide, so divided by 0.8, 66.17. So this is our final answer, 66.17. How much? 177. So 66.177. This is kilowatt. So finally we can write our answer is shaft power. Okay, the shaft horsepower required, or we got here 66.18. okay, this is kilowatt. This is our second answer. This is our second answer, and this is our first answer, that manometric head, or if you see that the total head generated by the pump here. Okay, I hope you understand here what is the meaning of this head generated by the pump. So here we have calculated only the head generated for one single one, suppose. Now here the total head is nothing but, okay, how many stages are there? Here 3 stages of centrifugal pump is given. So that means the number of stage is 3. This is for one stage. So the number of stage is 3 in the sense, so 3 into the HM. Okay, so here also we can consider the HM, there is no issue, but though it is given like multi-stages, that's why we need to write 3 into HM. That's what I have written here, the total head generated by the pump equal to 3 HM, and this value we got. So I hope you understand this problem, how to solve it. So some formula we need to remember. Basically this manometric efficiency formula, and this is the shaft power, or you can say that overall efficiency formula, because the shaft power is also involved in the overall efficiency. Apart from this, this is one formula at the outlet condition, U2 equal to pi dn by 60. Remaining all are simple. I hope you understand the problem. Still, if you are having any doubt and query regarding this, you can give a comment on the comment box. Thank you.